Hi there. So as Dave said, we're always a little bit more personable right after lunch. We're also a little bit more excitable right after coffee, so you're catching us at a good time.
Just had coffee.
So this talk is about Android application architecture. I'm Adam Powell. I'm on the Android Framework team.
I'm Yit Boyer. I'm also in the Android Framework team.
So this is actually going to be a little bit of a special extended edition version of a talk that we gave earlier this year at Google I/O. And just like every good special edition, the original version isn't available on video. So here you are. So the important thing about application architecture is really you need to act early in your applications. As soon as you start writing code, you've made these decisions that are going to affect how your application is going to be developed from there forward. So those decisions stick with you. These really, really deeply influence your application. We're going to show you a few of the ways that this really affects how you might write your app as you move forward. It really makes it easier or harder to think about the problems that you're really setting to solve in your application. So you might be asking, OK, well, which patterns do I use? There's a lot of stuff out there. And you can really kind of get into a lot of alphabet soup as you start looking over all of the different prescriptive patterns that you can look into for writing.
I'm super confused.
Yeah, I mean, I've got all these things here.
That's me, by the way. That is me. Just cartoonized.
So this isn't a survey of libraries. That's not what we're here to talk about today. There really are a lot of great libraries out there, and you should really look into many of them and see what they can do for you. But I mean, the trends change quickly. The challenges you're going to face are really timeless. The properties of some of these devices that we're writing for have been the same properties from the first time any one of us held a smartphone. And really, lava flow happens over time. This is kind of this phenomenon where after your code goes through a number of refactorings, there isn't really kind of an overarching principle that ties it all together anymore. Someone new who comes to your code base may or may not understand what's going on as you start piling up all of these different pieces that really no longer fit together. The important takeaway from this is to architect for user experience. Really, nobody in your user base is going to care exactly what patterns you used to produce your application. They're going to care about the experience that they have while they've got it in their hand.
All right, so let's look at some examples. Here's some videos. So here's an application. It's very simple. I'm posting a comment on a photo. I'm trying to type. All right, there you go, send, and I'm waiting. Why am I waiting? I have no idea. I'm just waiting. All right, it's sent. So what was the problem here? So what's happening was the user clicks on the send button. It goes to your controller, goes to your network. Network comes back whenever it wants to come back, and then you update your UI. Meanwhile, you block the user because you don't know what happened. Maybe the command will not go. What if we get rid of this? Introduce something you can call a model, which is your storage, which is where you keep your comments and everything. So then, when the user hits the send button, you keep it in your model, update the UI, then tell the network that this has been added, and you can, when the network comes back, you can update the UI. So let's look at the same example, this time with the fix, how it looks. So I come here, I type my comment, the same comment, so you make sure it's the same use case. I send it. I instantly see the comment. It's a little bit gray, but I see it there. When the network request finally comes back, it turns black. User has a clue. You can design it better. I couldn't, but that's the idea. You give the feedback instantly.
Your designers are wonderful. Make sure that you appreciate them.
Yeah. I told you, why did you give me a design job? OK, let's look at one more demo. OK, here's the same puppy. So I keep commenting. I really like it. I keep commenting. And I hit send. OK, you're going to see that it's grayed out. I see the response instantly. That's great. It turns black. That's great. I go back to that page again. It's empty. Like I was here literally 2 seconds ago. I came back to the page, and it's not there. Like this is bad. This is inconsistent. I feel like something got lost. So what was happening here? So the view controller, as we said before, told the model told the network, it came back, we updated the UI. Great. But the problem is, the model didn't have anything, right? It only is still fed by the network. What if instead you kept a persistent model? So is that your data stays on your client. There's something that you can always access unless the phone crashes, which you cannot do anything in that case. Instead, we have some application logic that's responsible to synchronize the network and your persistent model. It's really important to look at this problem as a synchronization problem rather than making API calls. That simplifies it a lot. So this application logic syncs with the network, fetches whatever you want to fetch, updates the model, then just notifies anyone. Okay, I'm done. I made some changes. Hey guys, if anyone wants to know about it, here they are. And then your view controller goes and fetches the data and updates the view. Let's say the user clicked on the send button. The view controller tells the application logic, I have this comment, please send it. The logic instantly updates the disk. That's the first thing you have to do. You update the local storage and tell, hey, like I updated this comment, I added this comment. And it also calls the network. Now there's two things going on right now. While you're making the network query, the view controller gets notified, okay, I have a new comment to fetch, goes to model, updates the UI. When the network finally returns, the application logic updates the model again and says, okay, I sync the comment to server. If anybody is instructed, like do something. And then the view controller goes, updates the view again. So I have, like, everybody has like very simple duties and they are decoupled. So how it looks when we implement it properly. I come here, it's instantly, because it's coming from the local storage, like it cannot be slow. Unless something is going really bad on your device, which sometimes happens. All right, so one more example. So, okay, it's running. So I'm so excited that I keep sending comments, but I'm only seeing the first comment I sent. Like something is, oh, okay, they just showed up. Like,
What happened there?
I don't know what happened there. I now figure out what happened there. So this was my background because I had this great pool on the background that processes all these things one by one so that I don't create too many threads. So when I loaded the activity to, like, a fetch bitmap job came for the photo and another one to load the comments from the disk. So I had two executors, they started running. Meanwhile, this user started spamming my application with all these new comments. I finished reading the comments, the other one came, we put the comment in the disk, and now we are trying to send it to server. Meanwhile, the network is really bad, so the fetch bitmap job is still running. The view controller got a notification about the new comment and wanted to refresh itself, but the QR is full, like I'm using, and then the job cannot run. So the UI is not updating because I'm trying to fetch a bitmap. Like, this is bad, that means the priorities are not good. But it's very hard to know, right? You don't know how long the job will take. You cannot estimate it all the time. But what you can do is separate these things. So if I have a different queue for my network tasks and a different queue for my local tasks, when my network is flaky, my application is still responsive because they are never affected. So if we run the same jobs that we run the previous scenario, as you can see now, they're going into different threads. And the local test queue just keeps running because disk is fine. Because we couldn't fetch the bitmap, we couldn't update we couldn't send the command to server, but who cares? User is still seeing it. And if we make that change as well, see just everything is sending. And as it gets time to run the server jobs, you're seeing that like they're starting to turn black from top one by one. They will eventually be synced. Okay, so one of the feedbacks we got after the I/O is like, okay, but how does the activity get notified? So activity is a very, very simple state machine in this scenario. When it is created, you set up your UI. That's all you do. When you start, you register for the events you want to know about, and you load your data. This is how it ensures that between restarts or whatever, if there's some events you missed, you will never miss them because on start, you register and you refresh your data. And when an event comes, just refresh your data. It's like the same thing over and over. On stop, don't refresh your data. You just unregister from events. So your life cycle is very, very simple. Like this happens, I do this. This happens, I do this. This makes it easier to test, much more stable, much more easier to understand. Okay, back to you, Adam.
All right. So the key takeaway from all the demo that we just saw there was really you need to design for offline. Always assume that the network is not your friend. It's going to be slow. And if you want to deliver a good user experience, you really can't just blame the network for why something isn't popping in quickly. The table stakes have really been raised on this when it comes to mobile. So to solve this, back your UI with a local model and use your other application logic to sync the model in the server, rather than doing this as live API calls. It can be really tempting to try to optimize for the case where you want data freshness above all else, where you really don't want to show anything to the user unless you're really, really sure about it. But this is one of those things where if you assume success versus assuming failure, then what types of claims are you really making about your software when you assume failure in the common case? I mean, your software is going to work, right? Your server is going to come back with the answer that you expected, right? So optimize for those cases, predict it, show it to the user early.
By the way, I just learned yesterday there's a fancy new name called optimistic rendering. So I feel like know what is called optimistic rendering.
Yeah, and I mean, this is something that you see this principle at work in a lot of other areas of software development as well. Games is one really prominent example. Where a lot of network latency compensation systems in multiplayer games are based on this principle. They predict based on what happened in the previous known state from the network. So you can use these same ideas in your own apps. So make sure that these things don't necessarily depend on each other unless it's in a very loose fashion. Use events and callbacks and such when needed to notify other parts of your system about state that's changed. So everybody always asks us about dependency injection as well. Is it good? Is it bad? What should I use? What library should I use? Well, I mean, use it if it helps. I mean, everything has a cost. So know the side effects of what it is that you're doing and what it is that you're including. It's very, very easy to include a new dependency in your application. And it's not always easy to see what the costs of that are going to be at runtime, especially when you're just bench testing at your desk. Everything is in the optimal case when you're sitting there at your desk. So avoid reflection for better performance as well. Many dependency injection frameworks have a heavy runtime component versus a compile time component. Some systems like Dagger 2 do this at compile time, and it ends up being much more optimal for your application. So take a look into these and see what the trade-offs are. When it comes to networking, so we talked about other things that we can do. Always assume the network is going to be slow, janky. Always assume that you've got your phone in the middle of a conference with crowded Wi-Fi and completely slammed cell towers. That's basically your case that you want to optimize for here, because this is when people are going to notice that your application is broken when it falls over. So your API design at the network layer can actually affect this as well. So design your backend for your client, not the other way around. And this is one of those things that sounds really obvious when you get up here and say it, but as you start building server backends for these things, you start exposing pieces that you may need, so on and so forth, and really you start building it up as a series of layers. So you have the very low-level components that provide your data, such as the network, and then you have the higher-level components that provide the presentation. And it's very tempting to not have the higher levels inform the design of the lower levels, but you can get a lot of wins by doing this. Also, process as much as you can on the server side to begin with. You have these big, beefy servers in the cloud that can do a lot of work for you. Don't offload stuff to the client that you don't have to. More specifically, pass metadata to the client. This is something that can really, really improve your user experience. If you have a large blob of data, such as a big photo that you're going to pull down as part of syncing some sort of social app, for example, what do you know about this image at the time that you've made this request and gotten this response back? Well, not a whole lot. So what are you going to show while that loads, while you actually go fetch that image? A better case would be to pass on along a little bit more metadata. Give your application some hints that it needs to succeed. In this case, we're passing the width and height of this image in advance before we go fetch the image itself. This allows us to perfectly size a placeholder in our UI so that you don't have your UI jumping back and forth as the user scrolls through or attempts to move back and forth. We've also passed along some palette information here just to be able to give our UI a little bit more of a splash of color that keeps the flavor of the image before we actually have the real bit. Battery and data. This is another concern that you've got whenever you're talking to the network as well, especially when you're doing any sort of background syncing. Batch your requests as much as possible. Now, we've provided a lot of other tools in recent versions of Android to help you do this effectively. Things like Doze and Marshmallow are great examples. Doze will do a lot of this for you, but really, don't just rely on that as your sole way of dealing with this. Doze is essentially the last line of defense for the user at this point. Use the job scheduler when it makes sense. Give Android as much information about what it is that your app is actually trying to do, and that way Android can make smarter decisions about how best to optimize that. The key takeaway here is act locally, sync globally. You really want to give the user a very fast, very responsive local experience whenever they're using your application. And then make sure that you keep that in sync with the cloud almost as an afterthought compared with the presentation that you're trying to give. So no talk of application architecture would be complete without some sort of addressing of the question of activities and fragments. This is something that we constantly get questions about. Even within Google, we'll get questions of like, oh, okay, well, should I use activities or should I use fragments to build my app? It's like, well, that doesn't entirely make a whole lot of sense, the question. Fragments are really just encapsulated parts of an activity. So when you build up your application, when your activity starts getting too big and you need to start breaking it up so you can still think about it effectively, it's a great time to break it down into some fragments. Or if you start by building single fragments that sort of compose together a little bit more than that so that you keep your concerns separated, that can help keep things a little bit more straight in your head so that you don't end up with these giant activity God classes. Fragments and views is another one that we get a lot. Now, this is something that we talk about quite a bit on the framework team in terms of like one of the almost regrets of the Fragment API at this point, is that you've got this handy little tag that you can just stick in your layout that says fragment and says, go ahead and instantiate a fragment and stick it right here in my layout when I inflate it. And this thing is really, really convenient. It makes for great code examples and demos because you can do things like have a layout that sticks two fragments side by side and then you rotate the device and it sticks them stacked on top of one another and you say, hey, look at this great decoupled system that I've got. It makes for a fantastic demo. But realistically, this makes people think of fragments as being view constructs themselves. And really, they kind of aren't. So they live in these very different worlds. So views are really the nuts and bolts of your UIs that you're building, whereas activities and fragments are the lifecycle constructs that basically provide the plug-in points of contact with the rest of the system that tells you what's going on. So many times, you're going to want to use both to keep these responsibilities clear. Just as you mentioned earlier, you're going to want to use the signals that you get from your activity and in conjunction with that through your fragments as well, if you're using those, to basically inform when you should register, unregister for events, so on and so forth. But the views should really kind of be their own encapsulated pieces separate from that are controlled by these other constructs. OK, so moving along to another topic of contention often, memory. So this is something that we talk about a lot. If you've watched any of Colt's talks on the Android performance practices, you've seen some of these. Avoid allocating objects in hot code paths. Putting pressure on the GC is not so great. Art is a lot better at this these days than Android used to be at all of this. But there's still a lot of those devices out in the wild. And if you watch this in a few sensitive code paths, then you're going to end up with a little bit of a smoother experience. So you can pool and reuse some objects when you measure a problem. That last part is really the key. When you measure a problem, make sure that you're measuring these things before you go and contort the internals of your system. And these are the sorts of things where some things you can make some decisions early that will help you move into these optimizations should you need them. And some things, it really doesn't matter. So write the code the way that it's clearer first and then optimize later. So GC still kind of remains your enemy, especially on some of these older devices, even as the garbage collector in Android gets much better. So perfect example of how this may affect your API design internally, just with smaller components. Now, what's the difference between these two approaches? Well, the top one is arguably more idiomatic, much cleaner. You can make some assumptions about it in terms of, OK, well, the object it returns is hopefully safe, if that's a mutable object to begin with. But in order for that to be true, then this getter has to be allocating a new rect for me that it returns. Well, now we've got allocation. So where do you end up using that? Versus the second form here, which is basically just taking an input parameter that the method is going to fill out. You know that the second one isn't going to perform any additional allocation in this case. This is the sort of thing that you really only want to worry about in extremely hot code paths. We're talking layout that gets run many, many times. We're talking drawing that gets run 60 times per second. If you're talking about things that happen in terms of your event handlers, like clicks and so on and so forth, you really don't need to be contorting your system this much internally. But for that very small percentage of your code, it is OK to write ugly code if it helps your users. Your users are not going to see your code. They're going to see your UI. If your UI is ugly because it's behaving badly, then that's something that they do see. That's something that really does affect their experience. The performance critical code really isn't the majority. And well, all compiled code looks ugly eventually anyways. So with that, we're going to move over to another demo that kind of brings a bunch of these ideas together.
OK, yeah. So after the I/O talk, one of the feedbacks we received was, OK, you talk these things, but show me some code. So that's clear. So this time we wrote a sample application. Keep in mind this is a sample application. And the main focus here is how do you look at this problem more of a synchronization problem. How do you design an application to work offline? And we are going to release the source code. I'm just waiting for some approvals. So here's my application. Oh, I just lost my Chrome. All right, let's come here. So it's a real app. Like there is a Rails server running on my computer just for the purpose of the demo. And the application is just a list of posts. Say hello, everybody, I can say. Or I could say everybody. OK. So how does this work? So let's do something dangerous. And just, it's not that dangerous. I will do more dangerous things later. OK, so I just disabled the network. And I send one more. So right now, like, please forgive my UI. But so there's an upload cloud on the right bottom of text that tells the user, this is not the same as the other ones. It's almost going to be sent. It's not there yet. So if I actually look at my Rails server, and my application, when the network recovers, it will eventually post it, and it's going to update the UI. Now, some other examples we saw in the previous time. Actually, we can crash the server too. So now the server is not running anymore. And so for this demo, I have a very simple backoff time, but it will just try backoff.
I mean, it does cry
these are
too.
my application. Yeah, it does cry too. These are my application logs here. It's actually keep trying to post it because there is network. It's just the server is crashing. And now when I finally bring the server up, oops, not like that, not like that. OK. So, I mean, it started backing off it will eventually send the command to the server. That is that it keeps retrying, and yes, it did send. So let's go one more case where we do crash the server again. OK, one more comment. This is the same. Oh, wait, it didn't crash. Oh, sorry, I crashed the logger. Look. All right, so we crashed the server this time. See, the application works. Hello.
You wrote a server that doesn't even crash right. Come on.
It should crash. All right, it should crash for the purpose of the demo. I hope your servers won't crash. So I say one more comment, and then I simply go out. Sorry, my emulator may crash, though. It's been having some problems. OK, I did go out, and I am going to kill that application. I come back. Oops. OK, so the comment is still there. It couldn't update the feed, but the comment is waiting for me there. And I will just run the server. It's going to eventually synchronize. So this idea, the application doesn't care about when the comment goes. It's sitting in the disk, waiting to be uploaded. There's some other job that's taking care of the upload, but it will eventually go to server, unless I have a bug, of course. So how do we take care of these things? The way it works is we have this feed activity. But by the way, again, this is a demo application. I'm trying to focus on certain things. There might be other problems with this demo application. The important takeaway is the thing we are focusing here. So this application, when you call send post, it simply tells the feed controller to send the post. which adds a job to the disk that's like something persistent that will eventually run, which is responsible to update the disk as well as sending the post. So it updates the disk and then dispatches an event. When this event is dispatched, my activity knows about this event, refreshes itself. When it runs, does the same thing, or when it's canceled, it does the same thing. This is a persistent job. That means it's going to be saved in the disk until it succeeds or reaches the retry limit. They say, okay, all right, the comment is posted, nice. And so another problem about synchronization, what happens if I'm offline, send comments. So it's not working eventually. And I go to this website and I create a comment here. I'm from the web. All right, this way. So now these two states are inconsistent, right? My client doesn't know about the new one. I have a comment locally. So if I enable my network, by the way, normally when the network comes back, you would refresh your feed. But I'm not doing it for the purpose of the demo. So when the network comes back, it's going to send the post instantly. And so it's out of sync, but when you eventually refresh, it's going to add the new one to the correct order. This is because everything is timestamped by the server. So until a post is sent to the server, you make a best guess timestamp on it. So for this example, the way I do it is, again, it may change per your application, but the way this one does is, wait, let me open the save feed job. Okay. So when it creates, it actually queries the model to get the best timestamp I have. This is a way to synchronize if my client's time is like really, really off, and if the new comment is not on top, that may look really bad. You can also change your server ordering, but UI ordering, but that may cause other problems. So what I do here is, like I assign a best guess timestamp locally, and then we do it on later on server. So we get off the network again. And again, like another case, because of the persistence, so I send a post here. Click on a username, moves you to the user's post. And it's there, like I never fetch this user feed, but the post is there. It's everywhere in my application because it's on my disk. I don't care if it is not synced or not. I have a proper model for that object. It's a simple value object, but it's always working. And let's say I'm in the user feed, but then recover the network. It will eventually set, and the feed will update too. If I go back, it's already updated here instantly. This is because like, if a UI is interested in a certain event, it listens for it. Now you could probably implement, I'm using a global event bus here. You can probably implement the same thing with RX or broadcast. Like, this is a sample application, it does this way and it works. There might be multiple ways to do the same thing, the right thing, or maybe a better way. So we'll get more fancy. Okay, like, what if the server is crashing? So this is my Rails server, by the way. It's a lot of fun. So magical language. So I'm going to turn on a flag here, which is going, what this will do is, the server is going to save the post, but it's going to crash afterwards. So I won't be able to realize that I could synchronize that post. So the server is crashing now. I go back here. I can say, okay, how is over? So the job tries 20 times and it backs off to 150 milliseconds exponentially. So it will keep try me again. All right. So now the server is crashing. As you can see the crash logs. It saved the post to the disk, but the client doesn't know. So the client keeps retrying. But what happens that your fetch feeds post endpoint is working fine. So I refresh. So the post came back. I know it's the same post. So how do I know it's the same post? This comes into a little bit API design, but we want to do a full demo. So I did figure out it's the same post and updated it, although my send post event never succeeded. So the way it works in this application is by design, each element is assigned a client ID. So if you look at these examples here, are they visible? Yeah. All right. So there's a user ID and there's also a client ID. This client ID is randomly generated and unique per user per post. So there's a unique key in my disk that says user ID and client ID is a unique tuple. You rely on the fact that it's not going to conflict, but yeah, I mean, technically it can, and probably it won't. So by doing this, when I receive the post from the server, I know that post already exists in my disk, and I update that one, saying that, okay, I sync this one, I don't know what happened to the job, I don't care. And then the job knows while running, when it, before trying to send the post, it checks, hey, is this already synced? So here, like, if you can see the code here, it just loads it, and if it's already synchronized, doesn't do anything. Oh, like, hey, this has been updated, good news, everything is working fine. So one more thing. Okay. So the most idea here is that like this works because we look at the problem as two separate problems. One of them is only responsible, take the user interaction, process the model locally. And the other one is responsible to synchronize with the server, however it does. It's not trivial. You're writing a bunch of additional code to say you have these like local client IDs, you handle conflicts, but it works. So let's look at one more demo here. This time, I will shut down the server. Okay, so I'm again that excited kid. I keep sending all these messages. Of course, they're not going to go. If I look at here, they are there, they're not going. When I recover the server, now the first job is backing off. It will eventually finish. Meanwhile, I can send more. As you can see, they are going up one by one in the correct order. Oh, my scroll position lost. This works because these jobs are running through the same queue per post. So I know that whoever came first will be handled first. So we guarantee that they're in order. We cannot guarantee their timestamps because this is technically not possible unless you want to rely on what your client timestamp is. But we rely on, we guarantee their order. Again, this is all independent of the UI. It doesn't care at all. The only thing it knows is how do I load this from the disk and how do I send these comments to my application logic. One more example I want to go through this code. So one of the problems with this event-driven architecture is, since all these events happening, how do I synchronize? Like, what if I miss an event, or what if the timestamps don't match? Again, for this demo application, the way this one works is every single event that is important comes with a timestamp. So for example, for fetching the feed event, timestamp is the timestamp of the oldest post. So that if someone is going to load those once, it makes sure it includes that timestamp in the query, so it loads things afterwards that. So every time the feed activity receives an event, let's say on event thread, it checks if it is for my user. If it is for my user, just calls the refresh with the oldest one. And then that refresh method, while querying the model, it uses that timestamp. Or if there's no timestamp, it uses the top one because you don't want to keep refetching things. Yeah, that is mostly. Let me see if I miss anything. Yeah. Okay, I think, so we are going to publish this code, both the server side and the client side, to GitHub as soon as, I need to add some clarification here and there. But, and you can play with it. We'll be happy to get pull requests or whatever if you think something could be done better. And it's nice to share and like, just move on from there. All right, so that's it. It's time for some questions.
All right. I think that we've got a microphone floating around, perhaps, or there we go.
Will it contain tests?
Huh?
Will the project contain tests?
Yes.
Yes.
Actually
Great.
does. So actually I should have showed it. So if you look at how well, they may not be great tests. I'm not a testing expert, but they do tests. They're mostly integration tests. If you look at something more fancy, for example, fetching the feed. So I say
Can we switch the slide back over to the computer real quick?
Oh, sorry. Can we go back to the computer? Okay,
There we
thank
go.
you. So the application uses Dagger. This is how I mock some of the API calls. But let's see, fetch feed now. Send command, that will be nice.
So short answer, yes.
Yeah, they're here. I had some very nice tests. I cannot find the, okay, 500, 400. So it's like, I mean, this is creating the job, mocking the API service so that if someone tries to send a post, return 404, then injects the test component, runs the job, checks the proper event is sent. So one of the things is, like it's not when some outputs happen as events, it's not very easy to test them. In this example, I'm using in the test application, I'm using a logging event bus that basically logs every single event so that I can assert on those later on. Again, like there might be different or better ways to do this, but this is something that works when we have tests.
Hi. What's your opinion on using custom views instead of fragments so you don't have to deal with the fragment quirks, if you will? So things like child fragment manager or popping in the backstack after you have save state.
So again, I think that they're kind of unrelated just because a fragment controls views. It's not a view itself. I mean, that was kind of what we were trying to get at a little bit earlier. Overall, I think that a lot of people write fragments when they really meant to write a custom view. So I think that in many cases, see exactly what it is that your particular chunk of encapsulated UI needs to express and respond to. If those are events that can be coming from some alternate component that's kind of composing that piece's place within the overall UI, then that speaks to it being probably a little bit more like a view group. If it's something that really needs to respond to other elements of the application lifecycle and the activity lifecycle, if it's doing something like registering for events, dealing with things like that, then it may be more appropriate for a fragment in that case. But overall, I think that people tend to lean a little bit too heavily on fragments when they think of one particular subsegment of their UI.
Hi. One question I had was, how do you handle the serialization of these jobs to disk and back out when the app dies? Do you roll your own logic, or do you use something like a framework or something?
So for this demo application, I'm using JobQ, which is some library I wrote before. You can simply serialize them. You can use tape. Like there was recently another talk to use tape to serialize your stuff to make it like a job. There's like multiple solutions for this out there. It's not that complex either. You can choose one of them which fits your needs.
Cool, thanks.
We've got one up front.
In this kind of application, would you use a sync adapter, or would you use like async REST calls to contact the server?
So for the demo, so one of the things we gave in examples in the slides was to separate your local tasks from the server tasks. The way we do it is, for UI related stuff, I'm using async task. I never use it for network, only for UI stuff. And for network, I'm using the job queue. So the jobs are the only ones that are calling the network.
Yeah, the sync adapter is generally useful once you have a more sophisticated account infrastructure and you have some of the other machinery that was really kind of built around. So if it seems like you're going through a lot of additional machinery to work with a sync adapter, then maybe start taking a look at some more things just like the job scheduler, so on and so forth, and see if that's something that is simpler that can still meet your needs.
When you start building all these applications with these different versions of data models, so you might have like fetch data off the network, updates that the user has made to the data that hasn't been actually pushed to the database. Do you guys have any classes that can help us maintain all this application logic, or any libraries that you would suggest we use to maintain all these different versions?
Do you have any particular suggestions? Or?
Nothing about versioning, but they actually remind me something I forgot. In this, one of the important things in your client is your client's consistency. And the server may crash, actually server may also start returning bad data. So one of the things this Clyde does is if I open a user model, let's say everything save. So before we save anything, we validate it. And if it is not valid for this client, we just throw it out because I don't understand. Maybe the server has a bug, maybe the server has a new version, I don't know. If I don't understand the object, I throw it out. This makes it easier for the rest of the application to okay, if the object is there, it's properly filled.
So to the point of dealing with specific data inconsistencies, especially across upgrades, different server versions, so on and so forth, what we found when working with a lot of teams, both within Google and external to Google, is that many times the actual pieces of business logic that make an app interesting tend to differ so much between applications that we've had a lot of difficulty finding a one-size-fits-all solution to just offer as like a prescription of, hey, everyone go use this for dealing with this particular problem space. It is something that you can make a lot of assumptions based on the shape of your data and what it is that your data is actually representing. So oftentimes you need something a lot less complex than some general solution that solves for the entire world. But if you've got some ideas, please track some of us down in the halls here, and we'd love to hear about them. Anyone else?
Okay.
All right. Well, thank you very much.
Thank you.